How can we minimize odor and produce quality compost with food waste? We know we have to add some wood or other bulking agent to reduce the moisture content and provide air space that allows the microbes to breathe. Some of us understand this as balancing the greens with the browns. For many of us composters, we want to use as little wood or bulking agent as possible because it costs money. And it takes up our valuable composting space. So we see what we can get away with. So what can we get away with? Here's where our learning tools, the small-scale composters, come in handy. We made 2 mixes, one with a small amount of bulking agent that gave us an air-filled porosity of 22%, and another one with more bulking agent that gave us an air-filled porosity of 45%. Compost experts tell us that the air-filled porosity should be between 35 and 50%. So let's see how we did. Here's how we did in terms of temperature. Based on temperature, we may conclude that the material with less bulking agent was composting much better because it gave us higher and more consistent temperatures. Temperatures remaining between 60 and 70 degrees for the entire 4 weeks. Let's now look at oxygen concentration in the composting material. The material with the lower porosity didn't quite have the same oxygen concentration, which makes sense. For the most time, oxygen concentration was between 12 and 14%, which is actually not bad. The experts tell us that we should maintain between 10 and 18%. You can see that the oxygen concentration with the 45% air-filled porosity was about 18%. So far, we have to conclude that there is no concern with air-filled porosity of 22%. So now let's look at airflow. These boxes rely on passive aeration, which is much like the chimney effect that we explained for windrows. And here's where we have a dramatic difference. The airflow was up to 10 times lower with the material having the lower porosity. Is this important? Does the final compost product give us any information on how we did? It does. We can see that the material with the higher porosity was substantially further along in the compost process as measured by respiration rate. In fact, the material with the 45% air-filled porosity easily met the CCME guidelines for mature compost after 4 weeks. How about odor potential? Measurement of the volatile fatty acids or short-chain acids are an indicator of odor potential. In this case, the material with a lower air-filled porosity had more than 5 times more short-chain acids. This is valuable information. In this case, it verified what our nose already told us. This is important and relevant information to understand when we compost food waste. In this case, it confirms what we've already been teaching, that air-filled porosity is important. We must take the principles learned on the small scale and apply it to larger volumes. It affects how we design our facilities, how we operate them, and it affects how the process may impact our neighbors. My name is John Paul. I'm a waste management specialist. Thank you.